Let's understand how to derive the third equation of motion using algebraic method. So, we know that our third equation of motion is 2as is equal to v square minus u square. Now here we will make use of the first equation to prove this third equation of motion. So our first equation is v is equal to u plus at. First equation is v is equal to u plus at. Now we know that we want something like v square, okay? And here we have v. So to get this, I need to make this square. So what I have done here is v, so I've just squared it. But we can't just take a square on one side. If I'm taking square of this side, that is LHS, then I have to take the square of this side also, that is RHS. So by squaring both sides, we get v square is equal to u plus at whole square. And now when we simplify this, we get v square means v square, and we know this identity, a plus b whole square, that is a square plus 2ab plus b square. So using that identity, we can simplify this. So with that, this u square, so u square, 2 into u into at. So this will give you the middle term, 2uat. And square of this thing, that is at. So a square and t square, that is a square into t square. So this is how we get this step. Now, understand this. This is very important. See, what we need to know is what is 2as. See, we need to have this 2as is equal to v square minus u square. And here we have v square and u square. And if I say from this, I can get 2as. Let's see how. See, in this term, there is 2uat. And in this term, there is a square t square. So, this 2, I will get common here. See, here there is a and here there is a square. So, from a and a square, a will be common. Now, the question here is, I have 2 here in this term, but I do not have it here. Then how can I get it common? See, to get rid of this problem, what we will do is, we will take out 2 as a common, but we will add one more number here, that is half. We can do this because when we will multiply, this 2 will be cancelled and we will be left with a square t square. Let's understand this now. See, I'm repeating this step. V square, u square. From this expression, I have taken 2 and a as common. So with that, I'm left with u and t. U and t, and that I have put here, ut. Now from a square, a is common. So I am left with a and t square will remain same because nothing is common. So this will be t square. Now I have to add half here because I need to get rid of this 2 and 2 so that a square t square will be same. Now, if you see here, just a minute, let me just delete everything. Okay, fine. So now, see, now we have v square is equal to u square plus 2a. But what about this thing? See, we know that from our equation 2 that s is equal to ut plus half at square. And this is ut plus half at square. So instead of this bracket, I can definitely put s. So if I consider this as my first result, And if I consider this as my second one, then again I can say that by replacing this thing in this, I will get v square, u square, 2a. But instead of this, I will put it s, because I know that s is equal to ut plus half at square. So I will get v square is equal to u square plus 2as. My equation of motion is 2as. So I will keep this 2as here and I will take this u square here. So this is in plus, so it will become minus. So v square minus u square. And this is how we can get our third equation of motion. So I can say that this is our third equation of motion by algebraic method.